Hi, in this video we're going to see how you can measure a tree with a fun trick. So the idea is to take two sticks of equal size. So here I'm going to take these two pens to represent the two sticks. The first stick, which we're going to call OM, is placed horizontally against the eye. So I'm holding that stick this way. And then the second stick, say AB, is placed vertically against the extremity of the other stick, so it's perpendicular to it, like this. I'm holding it like this. And then I'm going to step back until my IO is aligned with the top of the tree and the top of the second stick. So I'm going to look up and I'm going to see aligned the top of this and the top of the tree. And I'm going to do the same thing with the bottom of this the second stick and the bottom of the tree. So if you want to see exactly what it looks like, I made a little drawing. So you see this is OM is the first stick, BA, AB is the second stick. Okay, we're holding them, they're perpendicular, and O, B, and D are aligned, and O, A, and C are also aligned. So the first question that we have is that we know a couple of values of those segments, and knowing those values, we want to know what is the height of the tree. So what we know is we know OM, we know BM, we know MA, and we also know ON. So ON is 10 meters, MA is 2 centimeters, MB is 18 centimeters, and OM is 20 centimeters. So once you have this, it actually breaks down to a pretty simple geometry problem. We have BA and DC, which are parallel. So because they're parallel, we're going to be able to use the intercept theorem in two triangles, the first one being ODN and the second being ONC. So what we're going to do is we're going to say that the ratio of BM over DN is equal to the ratio of OM over ON in our first triangle, and in the second triangle we're going to say that the ratio of MA over NC is equal to the ratio of OM over ON. So if we write that down in equations, we have the following relations. We have OM over ON equals BM over ND. Therefore, ND is equal to BM times ON over OM. Now, if we replace with the values, we have ND is equal to 18 times 1,000 over 20. That's 900 centimeters, or 9 meters. We can do the same thing with a second triangle, and we have NC is equal to AM times OM over OM, which is equal to 2 times 1,000 over 20, which is 100 centimeters, or 1 meter. Now, to have the height of the tree, the height of the tree is DC, which is DN plus NC. So it's DN plus NC. That's 900 plus 100 centimeters. That's 1,000 centimeters, also equals to 10 meters. So the tree is 10 meters high. Now, there was a second question. The second question was the following. Why is it interesting to have the two sticks be of equal length? See, we took basically two sticks saying they were both 20 centimeters. Now, they could have been both 40 centimeters, but there's something interesting in having them of the same length. Now, let's see why. Now, the reason why it's interesting is that we have CD is equal to NC plus ND. So here we have ND plus NC is equal to DC, and the two following relationships. So what we can say is that CD is equal to BM times ON over OM plus AM times ON over OM. That's AM plus BM times ON over OM. And because AM plus BM equals AB, that's AB times ON over OM. So our two sticks are A, B, and OM. So if they're of the same length, then you can basically simplify this and have CD equals to OM that we have here. So basically, if the two sticks are of the same length, then all one needs to know to measure the height of the tree is just to know how far away we have to walk back in order to have the tree with the correct alignments with the sticks. So thanks for watching.